Oh boy. So I'm going to take on the challenge of developing a game engine from scratch, having had no experience developing games before, but having experience developing modeling and simulation environments using 3D visualization tools and libraries and such. Knowing that the complexity of a 3D environment can become extremely time-consuming, I think this game engine is going to start off as a 2D game engine and go from there. Now, before I jump into writing code, I want to go over my development environment real quick, just to give you guys an idea of what I'm working with so that you may follow along as well. I of course have Visual Studio 2019. I believe I have the latest updates. If I don't, I will update it. I have Sublime Text, which is a visual editor for multi-line commands and syntax highlighting. It provides all kinds of plugin support. Just a very useful tool, and it's my go-to editor personally. I have GitKraken, which is a GUI for Git that is free to use if you're using it for open source projects, or you can use a pro version for your own private projects. Has very nice GUI and nice editing tools for performing merges, that kind of thing. If I'm not using this, then I'm just going to use Git on the command line. And then I also have this Windows Terminal application, which has just been absolutely amazing to use. You can find it in the Windows App Store, and I also believe it's on Microsoft's GitHub page. So this, by default, will open up in PowerShell, but I also have the option to open up a command prompt window as a tab, or if you have Windows Subsystem for Linux installed, which I do, you can open up Windows Subsystem for Linux and do development that way. So I'll be making use of this along with my other development tools to accomplish this. So if you're like me and you've decided to develop a game engine, where do you start? Well, in my experience, having some kind of goal to work towards makes life a lot easier, and it helps you stay a little focused. So what I'm going to do is I'm going to grab an example from the SFML 2D library source code for Pong. And the way I'm going to go about doing that is I'm going to make use of VC package. So to acquire VC package, I will clone it from GitHub. And pull that down. So VC package, if you're not aware, is a Microsoft maintained collection of C++, C and C++ open source libraries, and it manages all of that for you. So I'm going to change into VC package, and once you have it cloned, I'm going to run the Bootstrap program, which will build it. This of course assumes you have a compiler installed on your machine. You'll be able to do the same process on Linux. So this is going to build the VC package executable. Once your VC package executable is built, you'll run the VC package command. I'm doing a / as I'm using PowerShell. Install, and I want the SFML library for a 64-bit build. So once you have SFML successfully built with VC package, your console output should look something similar to this, and it will give you the find package command for CMake in order to find this. And that's actually another tool I forgot to mention that I don't have on my taskbar here, which is CMake. So I'm going to open that up. so that I can pin it, and then we'll get back to that. So with with SFML installed, I want to grab the Pong example out of it. So I am going to navigate to the build directory of SFML. So VC package checkout, there will be a build trees directory, and these are all the libraries that were downloaded and built in order to compile SFML. So I'm going to come in here, go into the source directory, and there's an examples folder which has Pong. So I'm going to go ahead and copy all of this, and I'm going to temporarily keep that here in my Pong folder because I actually don't have my game engine project checked out. So my game engine, I believe I'm going to call funnan. This name doesn't necessarily mean anything other than the fact that it was a character I used to play in an old MMO back in early 2000s, and it was just a name that I always enjoyed having. So for now, I'm going to call my game engine funnan, and I already have it up in my GitLab project, so I'm going to, or GitHub repository, so I'm going to go ahead and check that out using gitkraken. With gitkraken open, I want to clone a repo. I want to clone it to my CLIO dev directory, the URL being GitHub. And clone the repo. Once it's cloned, we can open. So this is a brand new repo. No commits have yet to be made, so we're going to go ahead and initialize it with an initial commit. Looks like it gave me a readme. And I'm going to leave it at that for now. I'm going to go ahead and close this. I now have a folder called funnan. So when dealing with a C++ project, especially one such as a game engine that could technically get pretty big, and I have some pretty big plans for mine, I want to be able to organize my project in such a way that others, when they use it, will understand how to navigate it, and also that it would work well with VC package and its package management, and really other package managers as well, such as Conan. So I'm going to do a fairly standard project layout that includes a include folder where my public headers will go, my source folder where all private headers and source files will go. I'm going to also have an apps folder. This is where my example executables, my actual main executable, and maybe even a GUI editor at some point will go. I want to have a tests folder so that all testing can be easily found when someone new opens up this project. I also want a CMake folder where any useful CMake functions or macros that I end up developing for my project can live. I'm going to want a data folder. This is where just all collection of data for this engine would go. Any kind of character or sprite sheets that I want to keep in here, tile maps, input files, that kind of thing. I also want to have a couple of additional files such as a license. I'm going to use the MIT license. Hopefully this gives everyone the ability to copy, modify, merge, publish, distribute, etc. however they will go crazy with my software. This is for learning. Hopefully, not just learning for myself, but learning for anyone else who happens to come across this video. This Clang format file, if you're not familiar with Clang format, this, for me anyway, is life-changing. I have a bunch of configuration settings here that just tells you how your CPV files are to be formatted. Visual Studio has Clang format built in, so whenever Visual Studio sees a project with this .clang format file in it, I will be able to run a command after editing the file, and it will automatically format the file exactly how I like it. And this will work on all files that I touch, keeping a very consistent formatting across the board. And then a get ignore file to ignore some build folders and temporary files and stuff like that. So this is the main structure. In my include, I want to have my project name as a subfolder. That way, when this library is part of a collection of another set of libraries, all of the headers will exist in this include folder, and actually I can show you with VC package. Actually, I can show you with VC package. So VC package has an installed directory where all the built binaries exist, and this is the typical file structure you would find on Linux as well. There's an include folder full of library headers, and along with there's an include folder full of library headers. So if I were to develop funnan in such a way that that it can work with this style of directory structure, I would put it all in this include folder, and it would show up as funnan. So I'm gonna do that as well with a include funnan, and then my source files can just go straight to code. I don't really have any code right now, so let's get some code up and running. We have this Pong project. I'm going to go ahead and copy that. And like I said, executables are going to exist in this apps directory. So I'm going to call this Pong. I'm going to grab the resources. That's going to be your images and sounds, I believe. And now we need to get CMake configured in order to find that source file and get things building so that I can actually run this example. So I have a CMake file that I'm going to copy from. Usually when I have projects like this, I develop my files the same way. So the first thing we're going to need to do is create a new CMake list.txt file. This has to exist at the root level of wherever you want your source to be. And so since I'm going to be including source, test, apps in my project, I need a CMake list at this level. So I'm going to go ahead and edit this. I'm actually going to set this up to run with Sublime Text so that I can get the syntax highlighting. And let's see, CMake. Yep, there you go. So as you can see, Sublime Text has, and I have a CMake plugin downloaded and installed. And with that, I now get, I wouldn't say autocomplete, but it'll give you suggested examples based on what you're typing. So we want CMake minimum required. I actually don't know what the minimum version of CMake we can get away with my CMake style. So I'm gonna go ahead and, I know for a fact that this should work with 3.17. I think they're up to 3.18 or 19 at the time of this video. So your root level CMake list is what defines your project settings and begins telling CMake where all of your source files exist. The first thing you have to do is specify a minimum required version. I believe if you try to configure your CMake project without this, it will complain about not supplying one, so I'm just going to go ahead and supply one now. Hey guys, future Aaron here, editing his own video. I'm going to go ahead and speed up this CMake clip so that you guys don't have to suffer through the pain of listening to me drone on about CMake. If you do want more detail about why I'm configuring CMake the way I am, I can do another video that goes in depth to that, but for now I'll just speed through this and let you guys pause when you need to. Alright, we've set up our CMake project. I want to, we're going to need to write these project files for CMake as well, and we're also going to need to set up a couple more CMake lists. So I'm going to go ahead, add my project as a folder. Actually, let's add all of my projects here. We'll go ahead and save this. And this will allow us to do some really nice navigation of the directory structure by just hitting Control P and searching a file such as pong.cpp funnan apps pong. And here we go. The SFML Pong application that we're going to build and compile and link. Forgot what I was doing. We did CMake. Alright, so now we need CMake project. Alright, so I'm going to go ahead and copy. So once your CMake files are configured and good to go, it's time to actually generate our solution. To do so, we will specify the root level folder where the CMake file exists, which is in funnan, and then a folder for where all of your temporary build files are going to go, and the general standard for that is build. We'll hit configure, and I'm sure this will work first try. Another thing, since I will be making use of VC package, in order for CMake to automatically find the libraries in VC package based on those calls to find package, we're going to specify a tool chain for cross compiling, hit next, and browse to the VC package setup script, which is in scripts, build systems, vcpackage.cmake. We'll hit finish. And we have configuration errors. Not surprising. It looks like the first error is it doesn't know this file, generated export header.cmake. So if we browse to my folder here, I have generate export.cmake, so that's a whoops on my part. see what else we have here. Could not find GNU installer. I think that's because this needs to be plural. Let's find out. Hit configure. Unable to determine the install lib directory because no target architecture is known. Please enable at least one language before. So I think CMake likes to have enable language, and I think it's just CXX. Hit configure. That seems to have done it. The source directory apps does not contain a CMake file, so every directory under the root CMake list that gets included by the call from add subdirectory also needs to have a CMake list file. And as we see here, there's no CMake list file, so we're going to go ahead and create one. And add Pong as that subdirectory. Hit configure again. Unknown CMake command sfml add example under the Pong CMake list. So let's take a look at that. We are using the example from sfml, so it's very possible we're going to have to rewrite the CMake list in order for it to work with our project itself. So yeah, I think I am going to go ahead and do that. For starters, this is not the correct way to do a project anymore, so I'm going to go ahead and show how that works. We'll start off by calling project, and I'm going to go ahead and call this Pong. We're going to add it as an executable with the project's name, which will be Pong. We're going to list any sources for this project. They're only going to be for this project, so we'll mark them private. And the only source file we have is pong.cpp. So I'll go ahead and get rid of this old code here. Actually, before I do, it looks like we're going to need to add some dependencies. So if you recall, when I installed sfml, there's this command line output that specified that you can use find package. So I'm going to copy that, find it, and then I'm going to link the libraries that we need from it to my project. And again, this is just for this project, so we'll mark it as private. And it looks like they use sfml audio and sfml graphics. So let's give that a shot and see if this configures. Getting closer. Looks like we need to specify some components. Maybe this? Helps if you spell correctly. Oh, I believe I forgot a CMake header, so let's fix that. I think that is CMake package config helpers. Let's see if that fixes it. And we configured, so now we hit generate, and we've still got an issue, and that's because unknown export funnan config. I think I need to specify an install target. So let's try project target install which I've defined in my CMake folder under project install target. So let me actually spell that correctly. Project install target. See if that helps. And that does. So once we've successfully configured and generated our project, we just hit open. We want Visual Studio. And we've got some errors. Interesting. I'm not sure what's going on there. If I hit generate. So interesting. I don't know if it just needed to be regenerated or if I was missing some compile options. So here's our project. If we were to build the all build, then it would go through all of the sub projects and build them all. If we were to build install, that should give us the Linux install structure. And then we have Pong itself, and if we take a look at the source files, we can browse through here and look at the code. Now, this is expecting the project to know where resources is located, which we don't anymore because I've copied it into my own project. So resources is actually located currently here. So I'm going to go ahead and hard code that in for now. Let's go ahead and copy this, paste it in anywhere else. And now if we did this correctly, we'll build it. It'll successfully build. We'll set this as our startup project, run it, and we have Pong. Press space to start the game. And I lost it. That's about right. Alright. So I think the last thing to do for now is commit our changes, push them up, and call it a day. This will show all of the changes that we've added to this project. We'll stage them all. Have a short little commit summary to explain what we've done, which is initial CMake setup with a Pong example. I'll commit that, push it up to the master branch, and we are good.